Welcome back to the first lesson in calculus. Um, Sorry to be a little bit of a buzzkill, but it'll probably be a little bit of a letdown because the first lesson in chapter 0, we're looking at reviewing some big things, is linear functions. You're like, yes, calculus! Oh, I'm doing what I was doing in Algebra 1. It's okay, we'll get to newer stuff, harder stuff soon enough, but there's a little bit in here, a little bit of vocab that's a little bit new and different, but this is something important, and you know what? We're starting out the year, so let's jumpstart those brains on something easy. The very first part, increments and slopes. So increments is going to be kind of a new thing-ish. It's more new vocab than it's a new topic. And slope. You might be thinking, it's like, well, why are we even looking at slope? Calculus, or a big portion of calculus, is actually the study of slope. It's just we won't be looking at the slope of a line, we'll be looking at slopes of curves, kind of. But slopes is a huge thing in calculus because the slope is a rate of change, and that's what a good portion of calculus is all about. So, but what are increments? Increments is just a chunk of change. Like, how much did something change? Slopes and increments go hand in hand. A slope is, one of the things we think of slope is that's not an R, rise over run. All right, that's slope. Or the change in the y value over the change in the x value. You know, mathematicians, I have said, are very lazy. And by lazy, I don't mean that we don't work hard and we don't think. Lazy is just an efficient way of saying efficient. So we're not going to write change in y and change in x. We're going to use a symbol. And you may have seen this in your science classes. We're going to use the capital delta. It looks like a triangle. Change in y over change in x. And so the increment, how much are we moving in y for every how much are we moving in x? So if I had a slope that was, say, 5 halves, that means I'm going up 5 every 2 I go over. Or maybe I'm going up 5 halves for every 1 I go over. Those are increments. And honestly, to find increments, it's just the difference between the two numbers. The change in y is just y2 minus y1. The change in x is just x2 minus x1. And so to find the slope, I mean, that gives you the slope formula. So that's what increments are. Again, it's not a new topic, it's just a new vocab word to describe something we've already been doing. We have a few different forms of a line. The very first one is the point slope form of a line. And the cool thing about a point slope form of the line is it comes basically directly from the equation for slope. Slope, we usually use the variable m for slope. Do you know why we use the letter m for slope? No, neither do I. I've looked it up. They have like theories on why we use m, except that all the theories have been shot down, so no one really knows why we use m. But m was y2 minus y1 over x2 minus x1. Well, let's say that instead of two solid points, we have one point then that's fixed and another one that's moving. So instead of y2 and x2, let's just have this. These are our variables y and x. So m equals y minus y1 over x minus x1. And then I'm just going to multiply this to the other side. So we have m times x minus x1 equals y minus y1. Y minus the y point equals the slope times x minus the x point. That's the point slope form. This particular curriculum takes another step. They take this and they add it to the other side to get this equation. Now that's really important. Say in your assignment, you have to find the slope, the point slope form of a line. You can't have y minus something. It still needs to be y equals. You have to add it over. Otherwise, you're going to do all the work and have the question essentially right, but it's going to say, no, you have it wrong. So do make sure it's in the right form. How can we do this? Well, let's start with 2 points. Let's say the point 1, 3 and the point 4, 5. So with 2 points, that's as far away from the equation of a line as we can actually get. First thing we do, find the slope. The slope's going to be y minus y over x minus x. So we'll go 5 minus 3 over 4 minus 1. Remember, it doesn't matter which order you go in, as long as you're consistent. Since we went 5 minus 3, we had to go 4 minus 1. We couldn't go 1 minus 4. So 5 minus 3 is 2, 4 minus 1 is 3, so our slope is 2/3. Then, for our point slope form, we have our slope. We just need a point. We have 2 to choose from. We just need to pick one. It doesn't matter which one. Let's pick the top one, the 1, 3. So we're going to have y equals the y part of the point, 3, plus the slope, 2/3, times x minus 1. There we go. That's the point slope form. Now the downside to point slope form is that what if we chose the other point? We would have had y equals 5 plus 2/3 times x minus 4. That equation is different, but it describes the exact same line. So it's not unique, and that becomes problematic. So as opposed to the point slope form, which is really easy to write from information, a lot of times we put our answers in slope intercept form. Now this is that familiar y equals mx plus b. M is still the slope, b is the y-intercept. To do this, we simply distribute and then combine like terms. So if I start out with this equation, y equals 3 plus 2/3 times x minus 1, we can distribute those 2/3. Y equals 3 plus 2/3 x minus 2/3, and then combine those two constants. Y equals, that was 2/3 x, 2/3 x. 3 minus 2/3 is going to be 2 1/3, or I like improper fractions. 3 is 9/3 minus 2/3 is 7/3. There we go. That's the exact same thing we would get if we did it to this equation as well. Another form of a line is the general form of the line. And in the general form, the x and the y are on the same side, and we just have 3 things where a and b can't both be 0, because then we have 0 equals a number. That's not so good. So a and b can't both be 0, but one of them could if we really wanted to. That's where we get horizontal or vertical lines. Generally speaking, these are all integers as well. So if we took our equation that we have, y equals 2/3 x plus 7/3, the first thing I would do here is multiply by 3. We have that common denominator already, so let's multiply everything by 3. 3y equals 2x plus 7. Then we'd move the x over. So negative 2x plus 3y equals 7. Sometimes that number can't be a negative, so we'd end up with 2x minus 3y equals negative 7. I mean, these two are essentially the same, but that first number being positive is sometimes important depending on what curriculum you're looking at. So these all have their really good uses. The point slope form is really good when we're writing an equation. It might not be the final form of our equation, but it gets us into an equation. The slope-intercept form is a really good final form, and both those forms are really easy to graph from. The general form is not a particularly useful form for that. You can graph it. To graph it, I would find the intercepts. If x equals 0, what is y? If y equals 0, what is x? But the slope-intercept and general form of the lines have really good uses when we're dealing with application problems. That would be word problems. The slope-intercept form of the line is really good when we have that rate of change. You can rent kayaks for $25 an hour plus a $10 deposit or rental fee. How long can you rent it? It's where the hour is going to be your x, your rental fees, your y-intercept. You set it up. A general form of a line, like that equation, is really useful if we have, say, hats are $2, t-shirts are $4, you have $12. How many of them can you buy? So you'd have the 2x plus 4y equals 12. I can't remember what my numbers were, but it would be something like that. Like that kind of problem sets up super easily in general form. So those are the different forms of lines. And moving. Solving two linear systems simultaneously. I think I forgot a slide in here. Parallel and perpendicular lines. Remember, parallel lines have the same slope. Perpendicular lines, the slopes are opposite reciprocals. So you have to change the sign and flip it. So 2 perpendicular slope would be negative 1/2. Now into solving two linear equations simultaneously. We have done this a lot. We just haven't called it this big name. We generally call it linear systems. So we end up with something like this. And we solve. There's a couple ways of solving it. We can solve by graphing, which is not the best way. We will end up in times when solving by graphing is the only legitimate way of doing it, not usually with linear systems, but when we have different exponents and other things around, like it's not going to be solvable by hand, and so we would graph it and use the intercept feature to find it. But generally speaking, we have two methods. We have substitution, we have elimination. Substitution we solve for one of the variables. So let's say in the top question in the top equation we get x by itself. So that would be x equals 13 plus 2y. Then we plug that in, we substitute that into the second equation. So 3x instead of x, that wasn't a 13 at all. There we go. So we have 3 times 13 plus 2y, and then plus y equals 4. And now that's only one variable. So we can distribute this. 3 times 13 is 39 plus 6y plus y equals 4. You subtract that over. We'll end up with 7y equals negative 35. Divide by 7, y equals negative 5. Then we can plug that in up here. X equals 13 plus 2 times negative 5. That's negative 10 plus 13. X equals 3. So our solution is the point 3 comma negative 5. That's where those two lines intersect each other. So that's substitution. We could also use the elimination method. The elimination method is where we multiply one or both of the equations by a number, then add them together and to eliminate one of our variables. So for instance, we could multiply this bottom equation by 2. That would leave us with the top one, x minus 2y equals 13. Bottom one, 6x plus 2y equals 8. Now we're ready to add these together. X plus 6x is 7x. The negative 2y plus 2y goes away. That's the whole idea. They cancel each other out. And that equals 8 plus 13 is 21. Divide by 7, x equals 3. Then we can plug that into either of our equations. Let's plug it into this one right here. 3 times 3 plus y equals 4. 3 times 3 is 9, plus y equals 4, subtract, y equals negative 5. So again, we have our equation 3 comma negative 5. Our solution is 3 comma negative 5. So that's a quick overview of linear functions. It covers numerous chapters of previous courses we've done, but we've seen these over and over and over again. You should be able to do a lot of them without thinking too hard about them. So I'll see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.